Hello everyone. Uh, Today we'll continue our discussion on UPSC CSAT different topics. Today's topic is geometry. Geometry is basically a study of shapes, like finding their area, volume and related parameters. It involves both plane figures, which are two-dimensional figures, and solid shapes, which are three-dimensional shape. It also involves study of points, lines, angles, shapes and their properties. There are two main types, again, as we have seen, plane and solid. Plane is various shapes like circle, square, rectangle, etc. And solid includes sphere, cubes, like cube is something like this. I'm sure you must have seen, or cylinders, which are basically three-dimensional. Moving on, next topic is mensuration. It is the branch of maths which deals with measurement of geometric figures and their properties. Some important concepts in mensuration include area, perimeter and volume. Area is measure of the size of two-dimensional figure and is usually expressed in square units such as square meters or square feet. Perimeter is the distance around the boundary of 2D figure and usually expressed in units such as meter. So suppose this is the rectangle. Area of rectangle is the entire surface area, the area covered in this portion, and perimeter is this outer boundary, the length of this outer boundary. And volume is the measure of amount of space occupied by a three-dimensional figure. So the space occupied by three-dimensional and usually expressed in cubic units such as cubic meters or cubic feet. So if there is a cylinder, how much space it will occupy in the atmosphere will be the volume. So we will see like how all we can measure these things. So first thing is plane figures. The plane figure means the figures which are in 2D. First is triangle. So triangle are generally of three types. This is a simple triangle, and if all three sides are equal in length, it is known as equilateral triangle. Then we have a right angle triangle, wherein the one of the angle is 90 degree. This is right angled. Right angled means 90 degree angled. For any triangle in general, the formula for area is under root s into s minus a, b, s minus b into s minus c. S is the value which is given by a plus b plus c by 2, and a, b, c are three sides of the triangle. So area will be simply substituting these values and we can find the area. For right angle triangle, the area is half into base into height. Base is this length which is given by b, and height is this length which is given by h. So it is half into base into height. And for general triangles, it is this given by this square root formula. The third special case is of equilateral triangle. Equilateral triangle has all the angles 60 degree and all length of all the sides is same, which is, if it is a, this also a, and this is also a. The formula of area for equilateral triangle is root 3 by 4 into a square, and a is the side. The height of an equilateral triangle, height is this length from one tip to the base, this length. If it is h, the value of h is given by root 3 by 2 into a. A is again the one of the sides of the triangle. Moving on, we come to rectangles and square. Rectangle is a 2D shape wherein the length, there are two sides, length and breadth, and length is not equal to breadth. The area of the rectangle is simply given by length into breadth, that is L into B is equals to area, and perimeter is given by 2 length, because there are two sides, total 4 sides, L, L and B, B. So adding these, L plus B equals to 2 into L plus B is equals to perimeter of rectangle. And then we have square. Square is a 2D shape whereas both the sides are equal. If one is A, another one is also A. Area of square is given by A into A, that is A square, and perimeter is given by A plus A plus A plus A, that is 4A. In terms of diagonal also we can find the area. The diagonal is this length connecting alternative vertices of a shape. So for a square, this is equals this, if it is B, the value of B is equals to B square equals to 2A square using Pythagoras theorem. So B becomes root 2A. Moving on to the next concept is the concept of circles. So circle is a simple 2D figure whose area is given by pi r square, where pi is an irrational number denoted by 22/7. Area is radius is this length connecting center point to one of the perimeters of the end surfaces of the circle. This length is r, and if we have to find area of a sector of a circle, suppose this is the circle, we have to find this area. So to find this area, we need to find this is the thing, this angle. If this angle is theta, the sector of a circle, the length of the area of this part will be given denoted by this theta by 360 into pi r square, and length of this arc from here to here will be theta by 360 into 2 pi r. The perimeter of circle is given by 2 pi r. I hope this is clear. Moving on to the next concept is solid shapes or the 3D shapes. The first 3D shape is a cube. So cube is similar to a kind of matchbox wherein all the sides are equal. As you can see, this is the 3-dimensional cube. This is A, and this is also A. The volume of cube is given by A into A into A, which is A cube. The total surface area is given, one of the sides, suppose if we take this side of the cube, surface area of this side of the cube will be A into A, which is A square, and now we have 6 similar sides, so total will be 6 into A square. This is the total surface area. If we have to find lateral surface area means we are just considering 4 sides of the cube, one side, 2, 3 and 4, the back one. We are not considering this top side and the bottom one. If we ignore these 2 sides, we have 4 surfaces, so lateral surface area will be 4 into A square, that is 4A square. Moving on to the next shape is cylinder. So cylinder is equivalent to shape something like this. Now the radius, the r, is denoted by this. From this point to this point is the radius, and the height of the cylinder is h. So the volume is pi r square h. H and r we have already discussed. The curved surface area, basically this entire surface, the area is denoted by 2 pi r h. CSA equals to 2 pi r h. So curved surface area means area excluding the top and the bottom surface. Like I'll just take another color. We are ignoring this part and this part. So the rest part is 2 pi r h, and total surface area is 2 pi r h plus the area of top and bottom faces, which is pi r square into 2. which is denoted by this formula. Coming to the next shape, it is sphere. Sphere is simple, a 3D ball. The surface area of sphere is given by 4 pi r square and volume of sphere is given by 4 by 3 pi r cube. These are empirical formulas. You have to just remember them, which will help you in solving the problems. So this slide is the summary of all the shapes that we have discussed: area of rectangle, area of square, area of triangle, and then area of circle. These four quantities are area of rectangle, square, triangle, circle. Then three values: perimeter, a rectangle, square, and circle again, and then volume of a cube, sphere, and cylinder. So this will help you in remembering all the required values. Now the most important part, coming to PYQs. We'll discuss the PYQs from this topic and try to solve as many problems as possible in simple way. और मैं पहले भी कह चुका हूँ, हमें फॉर्मूले याद नहीं रखने, उनको अप्लाई करना है, वो अपना आप याद हो जाएंगे और चीज़ को लॉजिक से करना है, विच विल हेल्प यू इन अ लॉन्गर रन, बिकॉज फॉर्मूले याद रखोगे, अगर एग्ज़ाम में आप भूल जाते हो तो दिक्कत हो सकती है. तो हमें प्रैक्टिस करके उनको याद करना है ताकि वो स्पीड में बने रहे और हम आंसर अच्छे से निकाल सकें. So this is the first question. You have 1 minute and then we'll start the discussion. So it is given that 12 equal squares are placed to fit in a rectangle of diagonal 5 centimeter. There are 3 rows containing 4 squares each. No gaps are left between adjacent square. What is the area of each square? So this is a rectangle. Now there are 12 equal squares which are placed to fit in a rectangle of diagonal 5 centimeter. So 12 equal squares means if we can divide the entire rectangle in 12 parts. So we have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are small squares and we have 12 such squares. So each square will be of length A from both the sides. Similarly, this is A. So the rectangle has breadth of 3A and length of 4A, and it is given the diagonal is 5 centimeter. So from Pythagoras theorem, 3A square plus 4A square is equals to 5 square. That means (9A square plus 16A square equals to 25). A square equals to 1. That means A equals to 1. So area of each square is A into A square, which is equals to 1. So answer is C, 1. I hope this is clear. We have simply represented the question in a diagrammatic form. This is the rectangle which is given. It has the diagonal of length 5 centimeter, and then it is given 12 equal squares. So basically we divided the entire rectangle in 12 equal parts because there is no gap there are 3 rows, row 1, row 2, row 3, and there are no gaps between the adjacent squares. So each square, if the length is they are 12 equal, so length of each square is a, and if we place side by side, the total row length will be 4a and total column height will be 3a. Now applying the Pythagoras theorem, we can find the value of a square, and a square is the required answer where we have to find area of each square. Now moving on to the next question. You have another 1.5 minutes and then we will solve it. It is given a piece of tin is in the form of rectangle having length 12 centimeter and breadth width 8 centimeter. So it is a tin at 12 centimeter and width 8. What this is used to construct a closed cube. The side of the cube is. Now the area of this rectangular tin is 12 into 8, which is equals to 96. And as we have seen before, the surface area of cube is denoted by 6a square, where a is the side of the cube. Surface area is total surface area 6a square, and this is equals to 96. So a square equals to 16, a equals to 4. So the side of the cube will be 4 centimeter. I'll just repeat this. It is given a piece of tin is in the form of a rectangle. Now it is a rectangle of 12 centimeter length and 8 centimeter width. Width and breadth is one and the same thing. Now the area of this sheet, that means this cross section area basically, is equals to length into width, which is 12 into 8 equals to 96 centimeter square. Now this is used to form a closed cube. Now closed cube will be something like this, having each side of length a. So total surface area is 6a square, which is equals to 96, as these both are same. So a square equals to 16 and a equals to 4. I hope this question is clear. Coming to the next question. You have another 2 minutes because this will require some visualizing of things, and then we will solve this question. Now in this question, it is given in a plane, line x is perpendicular to line y and parallel to line z. So line x is perpendicular to line y. Suppose this is line x, this is line y. X is perpendicular to y and parallel to line z. So z is parallel to x. That means it is perpendicular to y also. It may be. Now line u is perpendicular to both lines v and w. And line x is perpendicular to line v. So line v and line x. So line x is perpendicular to line v. So v can be something like this. It is perpendicular to x. Now it is said line u is perpendicular to both lines v and w. Now u is perpendicular to v. That means u can be something like this. This is u. And now u is perpendicular to w also. So w should be something like this. Now let's see what all inferences we can draw from these conditions which are given. Z, U, W are parallel. Now Z is here. I'll just change the color for easy. Z is here. Z, U and W. Z and U are parallel, but they both are perpendicular to W. So first option is wrong. Now it is X, V, Y are parallel. X, V and Y. X, V and Y are parallel. V and Y are parallel, but they both are perpendicular to X. So option B is also wrong. Now let's see next option. Z, V and U are perpendicular to W. Z, V and U. Z, V and U are perpendicular to W. U is perpendicular to W, Z is perpendicular to W, but V is parallel to W. So even option C is incorrect. Now coming to the last option, Y, V and W are parallel. Y, this is Y, V is this and W are parallel. As we can see, all these three lines are parallel. Option D is the correct answer. I hope this is clear. We had to just visualize and draw this diagram once, and once we can do that, we have to just eliminate using options, because as we put in values, we will see different values, conditions are not satisfied, and we can easily arrive at our answer. Now moving to the next question. This is a very simple question. You have to just visualize things, take your time, and then we'll discuss it. It is given, the gardener increased the area of his uh, rectangular garden by increasing the length and decreasing the breadth. Length is increased by 40% and width or the breadth is decreased by 20%. 40% and 20, the area of the new garden. Now this is the initial garden, the length is A, let's assume length as A and breadth as B. Now the length has been changed, it is 40% increase. So 40% increment means it is now 1.4 B. 40% of 1 is 0.4, so it is B plus 0.4 B. And it is said the width is decreased by 20%. So initial width is A and it is reduced by 20%, that is A minus 0.2A, it is 0.8A. So 0.8A is the new width. The area of the new garden, we have to find the area. Initial area is A into B. The new area is 1.4 B into 0.8 A. This comes out to be 1.12 AB. That means the increment is 1.12 AB minus AB, which is 0.12 equals to 12%. See, the answer is B, 12%. I'll just explain it again. It is said a gardener increased the area of his rectangular garden by increasing its length and decreasing its width. So initially it was A and B, the length and the breadth. Now it is increased by 40% the length, and the width is decreased by 20%. Now it becomes 0.8A. So the new area will be given by this 1.4 into 0.A, that is 1.12 AB. And now we have asked increment, area has increased or it is same. So increment will be 1.12 AB minus AB, that is 12%. I hope this was a very simple question. Moving on, let's do the next question. This question requires visualizing things rather than solving things, because once you visualize what is happening, you can easily solve this question. It won't take much time. So you have another 1 minute, attempt it, and then we'll discuss it. नहीं time. Yes. Let's start this question. It is given the diameters of two circular coins are in the ratio 1:3. The smaller coin is made to roll around the bigger coin. The smaller coin till it returns to the position from where the process of rolling started. How many times the smaller coin rolled around the bigger coin? Now suppose this is the bigger coin and this is the smaller coin. If the diameter of the bigger coin is smaller coin is r, diameter is r, for the bigger one it would be 3r. Now it is said this smaller coin is made to roll around a bigger point. Suppose this smaller coin starts from this point, it will roll and it will roll the entire perimeter of the bigger coin and come again to the initial position. Now the perimeter of the smaller coin is equals to pi r, because r is diameter here, not radius. And for bigger coin the diameter is 3 pi r. Now when the smaller coin rotates one circle, it will cover a length of pi r. So suppose it starts from here, it will cover some length till here, which is equal to pi r. Then again it will roll, it will cover a length of pi r, and then again it will roll and it will cover a length of pi r. So basically to cover 3 pi r distance, and each rotation of smaller coin is pi r distance. The smaller coin has to take 3 rotations. It has to roll 3 times so that it comes to the starting position from where it started rolling. I hope this is clear. You have to just understand the question and visualize it. There's no maths as such involved here. I'll repeat again, there are two coins, smaller coin and the bigger coin. The smaller coin is of diameter r and their ratios are in, the diameter ratio are in 1:3. So the diameter of the bigger coin is 3r. Now the smaller coin starts to roll around from this point A, and it will keep on rolling until it reaches again this point A. For every roll, smaller coin covers a distance of pi r, and in total he has to cover a total distance of 3 pi r. So he has to cover 3 pi r by pi r, that is 3 times the length of the coin, so that it can reach from start to end point. So answer will be C. Moving on to the next question. Solve this question and then Like you have another 1.5 minute and then we'll discuss it. In this question, it is given there are two metallic cubes, not balls, which have volumes x and y, and m and n are the masses. So, there is a cube P and cube Q. Volume is x and y, and mass is m and n. Each side of Q is 2 times that of P. So this is suppose the cube P. This is suppose the cube Q. Now if this is length A, this is 2A. So volume of P will be A cube. For Q, volume of Q will be 2A cube. And it is given mass of Q is 2 times that of P. So that means N is equals to 2M. Now we have to find, let U equals to M by X. U equals to M by X. This is equal, since volume of Q is denoted by X, it equals to X. Volume of P was X and volume of Q is equals to Y. Cube. So Y equals to 8A cube. Now it is said U equals to M by X. Now, and V equals to N by Y. Substituting the value of N, we have 2M, and Y value we have 8A cube. And substituting, M is M and X is A cube. Now the relation between U and V is being asked. So as we can see, U by V equals M by A cube divided by 2M by 8A cube, which is equals to 4. So U equals 4V. That is A option. I hope this is clear. It was a very simple thing. There are two cubes P and Q. volume is denoted by xy, mass is denoted by m and n. Now it is given mass of Q is 2 times the mass of P, so n is equals to 2m, and each side of Q is twice the each side of P. So volume, if volume of P is a cube, the volume of Q will be 8a cube, because it is 2a whole cube. Now we have to just simplify the relation between U and V, which are in terms of masses and volume, and on solving we get this relation U by V as this, and this is the answer. Moving on to the next question. This involves the concept of cylindrical tank and underground tank. One is cylinder and one is a rectangular cuboid which has length given as this. We have to find the relation between filling of their volume. In this question, a cylindrical overhead tank. So cylindrical tank has to be filled from an underground tank of size this. So underground tank is there, which has a size of 4 meter, 6 meter and 5.5 meter, and this radius is 2 meter and height is 7 meter. How much portion of the underground tank is still filled with water after filling the overhead tank completely? So the volume of cylindrical tank, as we know, is pi r square h, which is given by 22 by 7, 2 square into 7. So this is equals to 22 into 4. The volume of tank is simply L into B into H, which is equals to 5.5 into 4 into 6. So after filling the cylindrical tank, the volume left will be, so volume left is equals to, this is equals to 132 and this is equals to 88. So 132 minus 88, and we have to find the portion which is still present in this tank. So dividing by 132, the original volume, we get 144 by 132, which is equals to 1 by 3. The answer is option A. I'll just bring a small recap. So there are two tankers. One is this cylindrical tank A and this tank B, which with all the dimensions which are given. Now water is transferred from this tank to this tank, and the question asks how much water will be left in this tank when this entire tank is filled completely. So the volume of this cylindrical tank is pi r square h, which is 88, and this volume of this tank is L into B into H, which comes out to 32. So now the volume left in the tank is this volume of the tank minus volume of the cylinder, which is comes out to be 44, and now we have to find the portion. So initial it was 132, so 44 by 132 is 1 by 3. So 1/3 of the tank is still filled with water. Coming to the next question. This question requires the concept of visualizing things, because there's not much maths, but we have to visualize what is happening, and once you visualize that, you can easily solve this question. A pole is a something that you can consider as a rod, and room is, just visualize things and then you can realize what is happening. Let's attempt this question. It is given, there is a room, so suppose this is the room. Now a rod is placed inside this room. Suppose this rod, the length of the longest pole that can be placed in a room. So suppose we have to place the rod, the pole. We can start from this end and take it to this end, because the diagonals are the largest thing that we can place inside a room. Now the lengths given are 12 meter, 9 meter wide and 8 meter high. Now this length is, this L is equals to this L, B and H. L square equals to L square plus B square plus H square. So it is L square equals to 12 square plus 9 square plus 8 square. This will come out to be root 289, which is equals to 17 meter. So the length of longest pole will be C, 17 meter, and that is the answer. So in such questions, we need to just visualize what is happening, and then using simple formula we can find the answer. We have to basically use these three values and determine the answer. As diagonal is the longest part of this room, so that's why we simply applied this formula. Next question. You have another 1 minute, and then we will solve this question. In this question, it is asking what is the maximum number of pieces of cake of this size which can be cut from a big cake of size this. So the volume of bigger cake is 5 into 30 into 30, and volume of the smaller cake is 5 into 5 into 10. So basically we have to find how many smaller cakes can be cut from this bigger cake. Uh, Basically we have to just simply divide the volumes of bigger and smaller cake to find the number of cakes that we can cut. This on solving we get 18. So 18 is the number of cakes that can be cut from the bigger cake. So whenever such questions are asked, we have to focus on the concept of volume, because volume is something that determines the number of pieces we can remove from a bigger piece, and that will help in finding the exact number. So basically this is a cake. Suppose this is the cake, and from this cake we have to remove smaller cakes like this. So the volume, the total number of smaller cakes, summation of their volume will be equal to the total volume of the bigger cake. So 18 such smaller cakes can be cut from this bigger cake. Like, we are trying to cover all varieties of questions so that you can attempt any type of question that comes in the exam, and it becomes quite easy for you to have good accuracy and maintain speed, and also get maximum marks. Coming to the next question, this question again requires a visualization. So first visualize what is happening and what is asked, and then we'll try to attempt it. In this, it is asked, we have to find the area of this shaded portion which is cut out from this square board of length 10 centimeter cross 10 centimeter. So if we see, there are 5 blocks of A. So the total 5A is equals to 10 centimeter, A equals to 2 centimeter, and each block has 3 squares: first square, second square, and third square. If we can shade this, and this, and length of each square is of length A. So area of each square is A square, which is 2 square 4. So each side has 3 such squares: 3 squares here, 3 squares here, 3 squares here, and 3 squares here. We have total 3 into 4, 12 such squares which are not shaded, and the total area is 10 cross 10. Total area is 10 cross 10, 100, and shaded area is basically total area minus 12 unshaded areas and area of them is 12a square. So putting the values here, total area is 100 minus 12 into 4, that is 48. The answer is 52. I'll just summarize. This is the entire board, square board, and we have to find the area of shaded portion. So we have to just delete the unshaded part and we'll arrive our answer. So entire area is 10 cross 10, and area of this shaded portion is basically each unshaded has 3 squares and area of each square is 4. So we have 3 such squares on each side, total 12 such squares, and simply we have to subtract the total area minus the area of unshaded squares to find the shaded area, and this way we can find 100 minus 12 into 4, 52. This covers your topic of CSAT, that is Geometry and Mensuration. This is quite a simple topic. You have to just keep on practicing and we can arrive the answer. If you have any doubts, you can always contact us. Thank you.